Go. Good morning, evening, afternoon, wherever you are. This Plasma Frontier. This is the one you've all been waiting for. Is Frazzle, and the topic is the generating system and the flight system. So please enjoy.
Thanks, Cleve. We've got Patrick here today, and so Joe. We're going to start today where we left off with the dynamic core. And a quick review, I'm going to bring up the dynamic core. And I'm going to do two photographs fairly rapidly, one right behind the other drawings. And the fun part is you get to see my notebook just as I show the team. These drawings are a few days old to kind of recap everything that we've been talking about. You remember we talked about the dynamic core, and it basically has the static core, which is the antenna with the PEX on the inside. It's got the copper wire around the outside of the PEX. The copper wire comes out, attaches to the steel wire or the iron wire, which then goes around the top of the pipe. It goes to the copper wire, which goes around the pipe again. It goes to the aluminum wire, which goes around the pipe again. One more time. So it's several wraps. You want to leave a space between the iron wire or the steel wire and the copper wire, and a space between the copper wire and the aluminum wire. The aluminum wire then connects to the wire that wraps around the outside of the PEX. Now, you'll see lightly another wire, and we're going to talk about this one at close to the end of this presentation. But keep in mind, we'll come back to this drawing, that there is another wire that we'll be using, and it attaches to the top of the PVC PEX above the joey caps, and at the bottom around the 1/4-inch PEX below the joey caps. That's those soda bottle caps and the tops of the bottles, and they're epoxy to it. So anyway, that's your dynamic core. Now we're going to go to the next picture, which is the shorthand version. Let me pull that image up. Oh. And what I'm going to do is I take some of the detail out of each of the drawings, and we start basically doing shorthand so that you understand what they look like. This next one is the dynamic core, basically completed without that extra wires attached at the top and bottom. This is just the static core. This is the spark plug, if you remember, that we're going to be dropping into our generator, into our flight systems. This is the spark plug. This is where the energy begins. This is the thing that harvests the ions out of the atmosphere, or harvests it from any plasmatic field that it comes in contact with. It's going to be taking a little bit in, building it up in the capacitance, the ability of this device to store plasmatic energy, and that storage is a result of the CH3 on the inside. It is a result of the nano coating. It is a result of the extra wires and the copper that's nano coated on the outside. All adds to the capacitance of this dynamic core. Okay, it basically is collecting energy, building it up to a point to where it can discharge to the next set of coils. So even though this one has a primary and a secondary coil in it, from this point on, this is going to be the primary as a total unit for the next part of the device. Stop share. Remember that shape. Bring up the next picture. We're just going to do a lot of pictures, one right after the other, because I want you to see how the thought process is on how these things go together. Bring this one up. I'll enlarge. Now, all I've done is drawn this black cylinder, which is PVC pipe, around the outside edge. In our builds, that happens to be 1.25" PVC. Okay, that's still smaller in diameter than the soda can that you saw in Mr. Kesh's challenge. This is we're heading to where we can hand in our homework assignment on the soda can battery pack, power system, power pack. And this is what we're talking about. I've added at the top the blue wire, which goes in and goes clockwise around the top of the PVC PEX, the top, the yellow PEX up there. And I've added the blue wire at the bottom, which goes up and it goes clockwise, starting close to the joey cap and going down towards the ground, which is in this case going to be the lead GANs, which is our artificial ground. In some of the other systems, they're actually going to be using an earth ground. And in a later video, where as soon as we had a chance to test it, we'll be looking at a hybrid that the ham radio operators have come up with, which is absolutely spiff. But for safety reasons and for right now, we're going to use either for those that are trying to try this, I highly recommend that you use the lead GANs as an artificial ground. And if you are using the flight system, I would take it outside. The more research that we've done on this in historical references, the more things that we're finding that we may end up with a lot more lift potentially than what was anticipated in the first place. We've scaled this thing down with enough built-in safety systems that we're only looking at a few ounces of lift or a few pounds of lifts, or just barely making the system lighter. We're not looking for liftoff or hovering at this point. We're looking at just seeing minimal shift in weight, and just for safety reasons. We want to get a chance that we can learn to control these things, manipulate them. If we get a little lift, we can get a whole bunch more very, very easily. And those of you that have been following along and seeing how we're setting this stuff up, you're going to say, aha, I've got it figured out, you know, how we're going to bump the system up. Yes, you've got half of it. We're leaving out a few parts just for safety reasons. But we're hoping that a lot of you are building this, and we'll see the little bit of lift, the lightening of the load to make it less heavy. Anyway, so we're using 1.25" PVC pipe. It slips over the outside, gives you lots and lots of space. And what's kind of interesting, and for those of you who had looked at our car units, this is very similar. This is how we got there. We basically have modified the CH3 GANs ball that was in the middle of the car unit and set it up with these coils wrapped around the outside edge. Everything is pretty even. It's just straightforward. Everything's wound the same way, anti-clockwise for the 3 rings. The top one on the the dynamic core is iron, the middle one's copper, the bottom one is aluminum, going around into the coil on the inside. So we're now going into the next part of the system. Stop share. Next picture. And I'm hoping everybody can follow what I'm doing here, because it's just super cool. Okay, I've done the best I could to draw a cutaway of your Magrav system. You've got 3 coils that wrap around the outside edge. This is basically your stacker unit. I think you could probably take one straight from the Kesh Foundation Magrav units, the ones out of Italy, and pop the lid open and drop the dynamic core right into it with this PVC pipe on the outside. Now, on the outside of the PVC pipe, which is in the middle here, let me get my pen out. And, we're the only part we're going to look at right now is this center. That's the PVC pipe. Once again, we're going to wrap a layer of copper wire around the outside edge of the PVC pipe. And it's going to be counterclockwise or anti-clockwise. It'll be iron at the top. The one in the middle is going to be copper, and it's anti-clockwise. And the one at the bottom is going to be aluminum, and it's round anti-clockwise or counterclockwise. It's, what's nice about this is the wire that comes off the bottom of the outside of the PVC pipe is going to go onto the outer copper of the Magrav coil on the bottom. We're going to separate the magnetical from the gravitational. And we're going to start with just using the magnetical layer, the outside layer of the Magrav. And I say we're probably going to we may have to rewire some of these a little bit. We may have to do a little bit of modification, but I don't think so. I think we can actually take straight from the factory and connect the top wire and the bottom wire, even without doing much more than that for the generator system. This part here, what we're going to talk about is strictly the generator system. We take the aluminum wire, attach it to your bottom lead of your Magrav so that the current is going to go anti-clockwise through the Magrav coils. Leave all the others connected just the way they are. There's a wire that comes out of the top of your Magrav system. That one will attach to the iron wire at the top. You should see a little bit of current developing in the plug-in strip on the outside. This isn't going to be enough to do much of anything. We're hoping that it'll light an LED light, one of those little cheap ones. I've fried so many LEDs over the last 6 months, it's pathetic. But your plug-in strip, everything is basically going to be ready to rock and roll as is. You may take your, instead of plugging into the wall, and do not plug in the wall with this thing, when you're using it this way, the house current is not compatible with the plasma systems, as we're finding. You may have to take the pigtail plug-in that you would plug in the wall and plug it into one of the receptacles on your Magrav plug-in strip. You may have to use one as to complete the circuit. Don't know yet. That's some of the stuff that we're testing. But anyway, if your Magrav unit has some capacitors in it, you're going to find that it's going to work a little better. And the generators are going to take a lot more capacitors to build up the power in it to do some work. But right now, we just want to see if you can either run a motor, a small little DC motor, or a small AC motor, or a LED. And you may not be able to use the plug-in, those pronged LEDs that you plug in to house current. You may not be bringing in enough amps and voltage to light a 15 watt or a 9 watt house LED. You may be looking at those little cheap 1.5 volt LEDs as your indicator to jump across between your positive and negative leads on your system. The other thing that you're going to have to do is look and see if you can get an earth ground for your neutral wire. And the reason is that you're going to be sucking plasma energy out of, let me clear everything. You're going to be sucking your plasma energy out of your dynamic core. Your Magravs are going to act as your secondary pickup. Your primary is your dynamic core. Your secondaries are going to be out here in the outer rings in your Magrav. The earth ground is going to be important on the side of the neutral. And you should be able, it should be, as we're going through this thing, your whatever item that you plug into it will just take will pull a plasma that it needs. At this point, we're going to be talking with some of our new associates, and we're going to be working on how to limit the runaway circuits so they don't occur. And we're looking at transistors, we're looking at resistors in the neutral lead to ground to slow it up so that you don't arc stuff out on the inside. Right now, as a quick test, this is what we're looking at. We're just in the process of assembly, and we'll be start dropping these things into standard Magravs. I'm going to show you, for those of you that have other systems or you've got extra coils laying around, what you may want to try to do. But I think on the double, the 3-stacker Magravs, there's a wire at the bottom and wire at the top. I think we can just connect them directly, top and bottom, and then your pickoffs to your power strips. You're basically going to be running your Magravs backwards as a generator. Just kind of a cool thing. Look at increasing the capacitance or the capacitors in your units to get more power and get your voltage up. What these things will do right at first, from what we can figure on what should be coming off of them, your 1.5 volt LEDs should flash like once every minute or two, or once every 5 minutes. You should get a flash. And what happens is that there's enough current buildup, there's enough plasmatic current built up in your capacitors that it discharges across the LED, which is a light emitting diode, which allows the plasma to travel in one direction. So it acts like a dam going to ground. And if you're using a cheap 1.5 volt LED, if you get a runaway circuit, you're going to fry that little LED, and that's your fuse. So it's not an expensive experiment to do. It's got some built-in safety because we're not doing that much modification to the Magravs as is. Now, for those that like to play with fire, we're going to go further. Anyway, proceed at your own risk. A lot of this is not tested. It's still in theory and still in R&D. We will not be building any of these units for anybody. We will be building them for ourselves. We will teach others how to do it, but this is one of those games you play at your own risk. Probably what we're dealing with, from everything that I've looked at, this is the cold electricity side of the equation, or the implosion side of the system. Your AC from the utilities is the explosive side. It's done on the expansion side of the system, and it's the hot, and the hot will burn you, the hot can kill you. The collapsing side of the field is that friendly plasma that you and I and the rest of us have come to learn to enjoy and love, that you can actually put your hand right onto the Magrav and it won't bite you. This is the coolest thing that I've played with in many, many years with my fun with Tesla coils, because the ones that I played with back in 2000, 2001, you get your finger anywhere near that Tesla coil and you got burnt. And it shocked it pretty well because it's going to ground. You can get some serious burns from them playing that way on the hot side. We're playing on the cold side. We're on the collapsing side. And there's as much or many times more energy available on the collapsing side rather than the expansion side of the electrical systems. Okay. Now, when I first put together the secondary coils, I built these rings around my plastic PVC, just like we did the Magravs, where I had coiled wire inside the outer coiled wire. And I used aluminum on the inside and copper on the outside on the bottom one. On the second one up, that ring, it was copper on the inside and copper on the outside. And once again, it was two springs, one on the inside, one on the outside. On the top, This is the iron wire. Are you guys starting to see a pattern here? I hope so. Around the top. Now, in that one was a spring inside of a spring. It was probably, mid-January when we first proposed this to the foundation, and we didn't hear much about it. And one of my favorite students from the private class, the Sandor, comes up and does his magic trick. And I'm sure many of you saw how to spread the coils by Sandor. And he took a thing that looked like a key or a ring maker's tool and ran it around and around and around and spread the gaps of the wires all the way around. Now, our team and myself laughed and said, well, how are you going to spread the inside coil doing it that way? And then we realized that Sandor was trying to tell us something. And what he was saying is that you want to make about 2 or 3 wraps around the circumference, or thread the wire through twice through it, like you do the tail of your Magrav when you're building them. Remember that long tail that you run through twice? Sandor just goes, are you watching? And he's holding this thing right up. And Joe says, did you see it? And I went, well, he didn't have a coil on the inside. He says, yeah, you didn't listen, did you? And I said, no, I didn't. He says, he's trying to tell you something. And it's that when we're doing the expansion on the magnetical, we want to collapse the gravitational. We don't want to be magnifying by putting in coils around here as a multiplier. We want to keep it as the smallest amount possible. So a ring around that is less material and less coil, so there's less multiplication by hundreds. And Sandor's smiling at us like, I hope you guys are seeing this. And it was like, okay, it took us a little bit to catch on, and it was like, thank you, and I'm thanking you right now for the insight that we had missed. So it's just basically a couple of loops at best around to hold the coils in place to give them their shape, and then your copper and your copper is wrapped around the outside edge. So in this one here, we're going to clear them all again, just for clarity. The bottom one, oops, pen, color, the inside of what we call the C ring is going to be aluminum. The inside of the B ring, as we call it, which is the middle stacker, that's going to be copper, a couple wraps of it. And the center wire is ringed around in the top, and that's going to be iron. We're once again using the dissimilar metals because we want to keep part of the flow going all the time, regardless of what's happening with the antenna. Just the difference in metals is going to set up that electrolysis, that galvanic current charge. Clear this. And because of all the nano coating that goes on to the copper on the outside, this is going to also increase the capacitance of the entire unit. So we're building and building and building. Now, one of the things that we discussed was the Frazzle flip. And this is one of those things that if you want to tear apart your Magrav and flip the B ring, just flip it over. You're not going to change any of these wiring settings on it. You're just going to flip that center one over. It's going to magnify the field interactions between the A, B, and C. And what you've got is a rotation in one direction and a counter rotation in the other, and then the other one runs the right way, and the same as the top. It basically, we find out, is called scalar wave technology. And it sets up a interaction with the bottom and the top against the center. And you're basically just setting up 3 toroids that are inversely rotating against each other, and it's really kind of an interesting process. Okay, we're going to go on. There is two things in the drawings in the nomenclature. I'm going to add two new symbols. It's actually one new symbol, and let me bring that one up so that when you see our drawings, you recognize what they're saying. Find it. In the past, I've abbreviated the Magravs, and I've called them one, oops, and there we go. We call it 1, 2, and 3. And this represents either your stackers, your 1, 2, 3 stackers, or the 3 in the V formation, so that you could have a drawing that looked this, and that would be your V formation, where those coils go down like so. Doesn't matter. It's how you arrange it. There's some interesting field interactions by how you set up your coils, how they react to each other. But on this new nomenclature, standard Magrav configuration, which looks exactly like where it comes from the factory or anybody else's drawing, is going to be represented on our line drawings as 3 curlicules like so. When you see it done this way, this is the center coil of the Magrav being flipped, and we're calling that the Frazzle flip. It's just changing the interaction of the fields, and this is a multiplier flip. Instead of adding up all the spaces in 1, 2, and 3 and multiplying that times 1, or whatever your known voltage is, we're flipping it, and it is the number of spaces of the first one times the number of spaces in the second one times the number of spaces in the third. Instead of it all added up and added, it's exponentially way more in the multiplication when you do the flip in the middle for increasing the fields. Okay, this will come into play especially in the flight systems. The Magrav systems for generator systems, at this point, oops, I'm sorry, I lost the share on it. Go back to it. The generator systems right now on our blueprints are going to be flavored as Magravs, meaning that a standard Magrav coil without much modification at all is going to be the generator that you drop the dynamic core into, and with just a slight how you attach to it to the center pickup coil will make a difference. And we might be able to just use the inner and outer coils on the Magravs and separate them for more advanced systems and eliminate the need for the PVC pipe. This is stuff that when we finally figured it out, there was so many more variables to play with than we ever dreamed of in the first place. We're calling you guys in around the world to help with figuring out all the different combinations, because at this point I can see just with the Magravs 27, 29 different combinations. So it's going to take some futzing and some playing to see which arrangement is going to give either maximum voltage or maximum lift in the lift system. It's going to take a concerted effort by all of you listening to this to go out and try it and to play with it. This is just our insight so far, and it looks really, really promising, and we need your help. It's going to be a worldwide project now. It's the race to who can find the best combination, and we're throwing the challenge out to you. So the flight systems are looking like they're going to have to be the flipped system, and I'm almost, I'd say 100% convinced that the flight engines will have the flip in the middle. After I got through with my revelations that, hey, I've got it, this is really, really cool, I started going back through the literatures, through the patents, and once again, Victor Schauberger, has something very, very similar, but instead of the Magrav units that we have that we're playing with, he was using counter-rotating plates. One at the top rotating, I think it was counterclockwise, one in the middle rotating clockwise, and the one at the bottom anti-clockwise, same as the top. That seemed, the rotation of these two sets up a field that negates the electromagnetic components of what we know as gravity. And there's enough indication that the work that Victor Schauberger did when he was in the Nazi concentration camp and had been put into making the entire Nazi UFO device, that he actually succeeded, even though he wasn't there at the time when the machine was accidentally turned on. His device went through the roof when it was fired up, and he was imprisoned. He was basically sent back into the concentration camp as punishment for sabotaging the experiment or the project, and it wasn't his fault. It had built up enough charge on its own to lift off, or somebody got the wires correct and the thing lifted off and blasted a hole through the roof. When we go to set these units up, I'm stressing strongly that you use the artificial ground, which is the GANs of lead. Don't use the earth ground at first. Don't take a nice clear day, a day that there isn't a lot of clouds and stuff, or rain, and set your unit outside to fire it up. I don't want to see, have the repeat of what happened to Victor Schauberger's team happen to your house or your garage. Take them outside. Be careful. Don't have your head over the top of them when you plug them in, and take a little bit of care. And no, we will not be building any of these for anybody. It's up to you to build them yourselves, and you will find it very rewarding, hopefully, and can help with what you find and post either to our website or our YouTube page or our Facebook page with your results. We really appreciate your input. But anyway, this is the nomenclature for the generators. It'll be the Magrav unit demarcation at the top. This will probably be your generators set up at this point. The flight systems will have the flip in the middle. Okay, clear. Stop sharing. Onward, fun stuff. Anyway, I want to get to the punchline because I'm just biting at the bit. It's this is so fun. So anyway, this is the outside of the PVC pipe. The demarcation on the left-hand side is the reverse on the Magrav, the Frazzle flip in the middle. Those are, each of those rings actually go all the way around, and it lines up with the similar metals in the middle. So when you're designing from the dynamic core on the inside, you need to keep in mind the ratios between the A, B, and C out here. And we came to the conclusion, because we're in our flight systems, we're actually building them conical shaped with a smaller ring at the top, a larger ring in the middle, and a much larger ring at the bottom, that the distances between these have to match up between the distances on the core. So you may have to extend that PVC pipe from the outside to the inside. So basically, on your builds, and some of the stuff that we stressed from the very beginning, what is your intention? What are you building? And stick with it. If you're building a generator system, it'll have a different look on the PVC pipe, the 1.25 PVC pipe, than if you're building a flight system. From what we're seeing, there's actually a small distance between the A wire and the B wire, and a much larger distance between the B wire and the C, because we're wanting that bottom gravitational toroid to be rather large compared to the other, so we get a plasmatic flow that is not, it's not balanced. Okay, there's a potential difference, because this one is smaller and this one is larger and that one is even bigger, that we're multiplying and getting a tremendously much larger plasma at the bottom. We may find out when we get through with this that, once again, Frazzle with his dyslexia has built things upside down, but because everything is modular, it'll be a simple project, simple thing to actually rotate that entire unit, if it's the flight system, 180 degrees. Just flip it over and go. Everything is set up so that in our blueprints we show that you can take these things apart and flip them, including the antenna in the middle, simply by putting in a cleave connector, top and bottom. Piece of cake. The ground stays in place, the antenna going up stays in place. You just rotate your dynamic core in the middle, plug it back in. So those are the things that are built into the systems to make the assembly process easy, and any modifications later on simply as easy to do, also easy. So anyway, next image. I'll try to speed it up because I'm running out of battery. Come on back, there we go. Go into the next photo. In shorthand, that's the system. We take the gravitational from the PVC PEX on the inside of the dynamic core, on the 1/4-inch PEX. We run that wire up to the aluminum wire inside the coils that go around it, so that it goes through, at first will be clockwise, and then the other is anti-clockwise. And it all works out because the wiring is done before you put it together. You wire all the systems in advance, and then you just flip them over. They're all built the same. They're modular. They look basically in construction identical. The plug-and-play connectors are put on in advance so that they can be nano-coated, and you just snap them together, and you can't go wrong because you've got everything laid out in advance. So you know that it just goes together very easy. So it comes up, and then the gravitational, of course, is going to do it in blue color. The gravitational is flowing in this direction, in opposition to the magnetical. And your magnetical is expanding and coming out past, oops, wrong color. red, is coming out as a toroid out of the PVC and out past your magnetical rings, either on your generator, on your Magrav generator, or on your flight system. They actually work exactly the same. One working in contradiction to in the opposite rotation as the other through the PVC pipe. It's a giant toroid. It looks like a giant donut. And instead of one field, you're actually having at least 3 and probably an infinite number of fields being made. What do I mean by this? Let's go to the next image. Okay, here we go. Schauberger gave us this idea, and it basically comes from his work with water. And what he did, in my blue, he had a beaker of water like this beaker, a little hole in the bottom. When the water drained out the bottom, because there's negative pressure right there at the opening, it sucks the water out of the beaker. A tornado forms inside the beaker. A vortex forms. It's like a big old tornado. And it's not just a single cyclone, it's actually a double cyclone. There's 2 of them in there that form. And it's partly because of the interaction of the gravitational and magnetical, but it's in water. But you get this ripply toroid, vortex forming. And then if you closely look at it, there's thousands and millions of little vortices forming, feeding the 2 big ones. So it's a vortex inside a vortex inside of a vortex inside of a vortex. Very, very cool stuff. So we clear. So what I'm trying to show is this vortex forms like this in the middle. This looks like a V or a little tornado. And then at the bottom, it forms several little tornadoes that are very erratic. They just kind of splatter out, but they do have that cyclonic effect. You'll have a rotation at the top, and then whatever way it goes will be the same as at the bottom. It just continues through. So we take Schauberger's work and we say, does that apply to the plasma systems? Yes, it does, in even a different way, but it's similar. Stop share. Go to the next image. What we're looking at when we're looking at plasma fields is when we come in with our no contact voltage, is it starts to ping, it starts to go beep, 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 beep when we get in close to the plasmatic field. And we can actually measure the edges of that plasmatic field, and we see that it has this toroid shape. It looks very similar to the iron filings on a piece of paper when we put a magnet below it, and it even looks closer to it when you have the field viewing screens that are green that you place over the top of your neodymium magnets, and it shows these 3-dimensional toroidal fields. They line up just like the grains of iron filings, but in 3-dimensional toroidal fields, meaning that much like your magnetic fields, your plasmatic fields have more than one magnetical and gravitational. The red being, for our purposes, being the expanded magnetical, travels out from the top and around and into the bottom. The gravitational, which is blue, goes in the opposite direction. I'm going to challenge you right now, all of you that are listening to this, and I want you to rethink what you think you are observing with your voltage meter, the no contact meter, when it pings. I want you to take a refrigerator magnet and place it on this, away from, when your device is on and away from electrical field. Place the magnet around or by, up and down the handle of your device. On the inside of your meter, this field, this no contact pen, there is a magnetic reed switch that when it comes in contact with a magnetic field, it closes the circuit and gives you that beep, 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 beep sound, okay? If you take a magnet and you put it onto your iron GaNs, your CH3 GaNs, on the magnetical portion of it, you'll find it is not attracted to the magnet, but the gravitational is attracted to the magnet. What we're saying is, and why I say magnetical instead of magnetic, is because the magnetical field is expansion, it's pushing away. The gravitational is what pulls things towards it. When magnets come together and you're watching them with the plastic screen that gives you the view of the plasmatic fields, you will see that one of the fields will disappear, and it'll be when the two magnets come together, and the magnets will take on a singular field together, a combined field. What we're challenging you to think about is that, by definition, instead of saying something that is, you know, magnetic, when the magnet attaches to, like the refrigerator, that's a magnetic attraction, to stop and say maybe it is a gravitational attraction that causes these two bodies to come together. Otherwise, they would repel. So a gravitational pull is the part that your meter is picking up. So instead of picking up this red magnetical field, chances are you've gone through it. You've already passed through the magnetical, expansion magnetical field, and are picking up one of the gravitational bands. And that's why your meter is going beep, 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 beep. Test it, think about it, see if it fits with your logic. Later on, when we go into the anti-gravity devices, you're going to see why I'm pushing for this different thought. It's kind of like when the first time they told you that when you look at a red apple, the apple isn't red because it's a reflection color that you're seeing. The red is being, everything but red is being absorbed by the apple. And what is red that is reflected is what the apple is not. When you have projected light where it's going through, let's say, a red film, then everything that is not red is blocked, and only the red light is what you see through the projection. Okay? The colors seem to be the same, but that is just a learned response by you as a human observing. So reflected color is not that color. It's the object that you're reading is not that color. It's actually the inverse. When we're taking a look at these magnetical fields, what you think is the magnetical field that your device is picking up is actually the gravitational field. There is another gravitational field. Clear all this. So we have one blue one right there. There's actually another one above it, and even another one above that. So if you check with your devices, you'll run into these because they're much larger, and they may expand completely outside of the room that you're in, and they may, in fact, connect outside the universe. It's hard telling how far these actually travel, so keep this in mind. So anyway, this is that magnetical gravitational toroid that we're looking at in a simple single coil, like a Magrav coil on a stacker unit. Looks like that. or if all your Magrav coils are lined up the same way, they form a large toroid as if they were a pipe, or they were magnets stacked one on top of each other. You get a single toroid. If you reverse one in the middle, you're going to have a completely different toroid formation. Okay, now stop that one and pick up the next picture photo. Okay. 2, 3, 4, where are we at? When we take a look at our PVC pipe, this is that 1.25" PVC pipe with the 3 different rings on it. I've cut away all the different fancy colors. Remember, the top one is iron. That top ring, right above that, right there, is the iron. The middle one is copper. Oops. The middle one is copper. The bottom ring is aluminum. Clairol. It sets up a magnetical current that comes out of the top and runs out just like gears on it, 2 gears coming together, out of the top and in the bottom. So it has a look like this. Stop sharing. The next one and I'm going to really belabor this point. The next one, the gravitational, comes out of the bottom and goes into the top. It goes in opposition. Stop share. Next one. What we're looking at when we set these up is, in the case of the 1.25" PVC, we're setting up toroid rings that look like so. And depends on how much pressure builds up, how thick each of those bands are. Okay, they don't have to be really fat. They can be narrow and close together, or they can all be really fat in the middle. Or there may be some in the gravitational will be really small and the magneticals will be really big. Or you may find that we want the gravitationals really large and the magneticals really small. These are things you can play with in how you set up your wiring and where you do your positioning. I'll show you, that's really fun. What happens when you set up your magnetical, it'll follow the outer edge of your copper wire because it's the magnetical expansion. So part of that field coming out of the center of that PVC is going to interact with your flight coils or your Magrav coils, and you'll have this band of red, this expanding magnetical, going out past them. They're going to interact with each other, and they're going to hold that field in that position. Stop sharing. The next one is the gravitational. All I'm doing is now I'm going to add in the gravitational line of that toroid. And it's going to try to follow the gravitational wire that is in the inside. It's basically going around. What's interesting is the progression from the inside to the outside, where the magnetical wants to go from the iron to the copper to the aluminum. The gravitational wants to go from the aluminum to the copper to the iron and dive into the PVC. So you've got this current countercurrent of gravitational and magnetical happening at the same time. Stop sharing. It gets more complicated. Not really, though. We're just learning to look and see with our mind what is happening with our systems. This one. So you have a magnetical and then a layer of gravitational go in the opposite direction, and then a magnetical on the other. I want you to take a close look at the gravitational wire. It's coming in and it's picking up on the outer side, on the convex side of the inner plasma field of gravitational. Go back in. It's on the convex, on the outside edge, it's picking it up. Your wire comes up and actually busts through the magnetical and goes into the wire on the inside. Which field does it really interact with? And you notice that we're not connecting that top wire with the bottom wire. There's actually a gap. Why? Because it forms a wireless connection from the top to the bottom. There's a gap in there. It's like a giant spark gap. It's a giant capacitor being made right there by the plasmatic fields. So you're taking from the convex portion of one gravitational field and throwing it into the concave and increasing the collapse into ground. That's how cool this is. You're basically doing division on the gravitational and do multiplication on the magnetical, multiplying the magnetical field and dividing the gravitational field. If we've done it backwards, it's just a matter of reversing the process. So even if what we do increases the weight of our test engine, this is a good answer. It's not a wrong answer. It worked, but it worked in reverse. If it gets heavier, we expanded the magnetical and collapsed the gravitational and makes it heavier. Well, we need to do the opposite. We have to expand the gravitational then and collapse the magnetical, and then you have lift, because you're changing the gravitational center or attraction of your spaceship. Instead of being earthbound, it's now going to be bound to that ferrite CH3 core, which is an artificial gravity inside your device. And when this is the same charge as this, it repels, and you are thrown off of the planet. You're thrown away from the planet as two positive charge magnets would repel themselves. That's the lift engine. That's the excitement of this, what we've come through with all the research that we've looked at with all the different people from Tesla to Victor Sauberger, some of the work that has been done so far by the teams in New Mexico, John's teams and stuff, the work that's been done by JC out of Canada with the car and the Peruvian systems. This is what we're looking at. This is the correlation. This is the link that puts all those systems together. You're not building just one unit. Your antennas are your health pens. It's the same winding, very similar to your health pens. They work just the same way. Your generator component is your Magrav unit. It's just running it basically backwards. The step up, step down the step up and step down coils that we see in the Joule ringer circuits is the Magrav circuits. It's what makes your step up in voltage or your step down in voltage. Your capacitors in this builds up your charge so that you can harvest it what you need. So your antenna in the middle is basically your fuel supply, which builds up the energy in your capacitors or the capacitance of the device. And then the discharge is either going to be in a plasmatic form in the form of the lift engines or in electricity in the Magrav systems. And basically what we're saying is that two systems work together in your infinity loop. And if I had a whiteboard right now, we're right back into, is it a lift system or is it a generator system? Is it magnetical or is it gravitational? What part of the loop are you working in? What part of the system are you working in will determine what you get out of it. Whether it's lift, whether it's electricity, whether it's healing, whether it's food GANs, whether it's an interaction of the resonance of your plasmatic devices with the resonance, the frequency resonance of your GANs, or in liquid form, or on the wires that you nanocoated and then treated with the GANs. Okay. In addition, we're looking at what we're going to do to treat each of these wires in the lift system, and that's going to be a separate lecture. But you've already been given it. It's in the previous ones. It comes right straight from the amazing first step. We've gone full circle, 360 degrees from that very first one. We've gone all the way through the infinity loop. We've gone all the way around with the car systems, the wireless transmissions, the gravitational, the anti-gravitational, the magnetical, electromagnetical, electrical system, to realize that what we've got is basically one great big machine, one great big device that all of us have been building all the component parts already, and they're right in front of you. The only thing that we may have to do to get this thing to work is to ping the antenna. And that one may have to have a high voltage ping to it to get it started, in the line of either a transformer ballast from a fluorescent tube, a taser, even possibly just something as simple as electronic fireplace starter. You know, those ones you buy for $1 and you click it and it has a little spark. That spark is around 1,000 volts. If you don't have the propane on or the butane on, that little click against that antenna may be all it takes to get the system to jump. You see, this is what Douglas did when he ran the aquarium motors backwards. Those are brushless motors that rotate in a magnetic field and throws out a higher voltage dirty AC current or dirty DC current, and it gets enough voltage and amperage to fill up the capacitors. We may have to fill up the capacitors first before it'll discharge to ground. That's some of the experiments we'll be working on next. We're going to be working on capacitors. But right now, you have all the components in front of you. You know how to make basic capacitors. We'll be looking at seeing who's got better capacitors, easier to make and longer lasting. There's been a lot of work on the web right now by several people, and we're looking forward to seeing what the rest of you come up with what we've given you all today. We hope this helps. We hope this gets you moving forward to not needing or not depending on fossil fuels, not needing to be dependent on the grid or electricity. This at first may be just simply a simple auxiliary power system for when the power goes off. And when we start manipulating these fields, like I'm showing you here, we may find that if we set up several, that we're going to end up with an interaction between these that may set up a third plasmatic field that gives us the shelter, the static shelter. It's going to take some work. It's going to take some basically interacting with the fields. So I'm making a nice mess with this, to give you this thing that, even though it isn't solid, has the appearance of being solid and sets up a resonance that doesn't allow the rain to come in. It doesn't allow outside electromagnetic energy to come in. It gives the illusion of something, be it aluminum, be it copper, be it iron, be it fiberglass, be it a skin that's like an orange. Whatever it is that will repel the elements is the first stage that forms the spaceship that allows us to go off planet safely in our human space suit body that we are currently in. So is this the final engine? No. Is this the final solution? No. What this is possibly one solution that there may be hundreds of other solutions that are as good or even better. But if we get the first one going, we get the first ones up and flying, then we can look at the other systems. They become aware. We started seeing things in a different light when we started doing the construction. We started seeing the innovations almost immediately where we could have done it better. But since we didn't build it, we didn't know. So we built it, and then we said, oh, if we put this slightly different, it'll be better. So we start from the beginning. Are you going to be building a generator? Build a generator from the scratch, from the beginning to the end, complete. If you're building a lift system, a flight system, build a flight system from the beginning to the end, complete. If you get to where you're not happy or you come to a block, set it aside until you're ready to finish it. It took Joe and I almost 30 days to put the last 2 wires onto our power system. It takes a bit. It isn't fear. It is, did you get it right? Do you understand what's there? When you finally get it in your head, you finally see it, then there's no problem. These things slap together rather easy and quickly. When I put the car unit together, it assembled a lot faster than I ever thought it was going to. The same thing goes with the dynamic core. The same thing goes with the generator and the lift system. When you're first putting it through, there's a lot of hesitation. There's a lot of holding back, going, did I do it right? Did I get the wires right? Did I get the GANs right? Get to where you understand these systems thoroughly from the inside out. Go through the drawings, go through the explanations, watch the videos, pause the videos, replay them until you are intimately familiar with each and every part of the system that you're building, that you could dance through it in your mind with your eyes closed. That's how well I want you to know your systems, because then if something goes wrong, you know how to repair them, how to build them, what the modifications could be to make it better, because it's sitting right there in your mind in 3D form. So have a great day. I hope you've enjoyed this video. Thank you, all of you who have supported us financially over the last 60 days. You have no idea how much help it's been. The donation button is at the bottom in the notes at the bottom of the page. Clear that and stop share. Okay, guys, comment.